Hi, Max.
Hello, Elena.
Thanks for coming and joining us for this course.
Well, it's a pleasure to be here.
You are a climate scientist, right?
Yeah, I've been a climate scientist in different capacities. At one point, I was an actual research scientist at Columbia University. In my current capacity, I work for the World Meteorological Organization, so it's a United Nations agency, but we still use and apply and actually synthesize climate science and data on a daily basis. So I think I can still say I'm a scientist.
And today, how does it feel to be a climate scientist in your daily life, in your hobbies even?
Yeah, I play on an ice hockey team with people that work in the oil and gas industry and they're traders and so on, and I'm kind of surprised, honestly, that they're not really that aware of it, and sometimes they say, oh, I've heard about this, it's a bunch of nonsense, and you know, if you're in that business, you ought to be aware that your business is not sustainable, and you might, even in the course of your career, run into some of those things. So I do try to find ways in my personal life to you know, discuss this without becoming a bore, but unfortunately you wouldn't want to have me at a party, because the usual trajectory is, what do you do for a living? Oh, I work on climate change. Oh, here's my take on climate change. And then I say, listen, let me tell you, and I start into it, and by the end we're just talking about the end of the world.
Oh no. So what would be the three things you would try to say to convince them about climate change from a scientific point of view, let's say?
Well, generally speaking, one of the things that people can now begin to use as a reference point, if they want to, is their experiences in their daily life. The climate has changed over my lifetime. Winters are not what they used to be, and these kinds of periods of intense heat in the parts of the world that I've lived in did not occur as frequently or as much. So farmers, people that are, you know, either sensitive to the climate, interested in the climate, or their livelihood depends on the climate, you know, have observed these changes now. And if you wanted to, you can look at the satellite imagery of the ice caps, and you can look at video of gushers of water off of glaciers or out of the tundra, and you can see the melting occurring. You don't have to go to a climate model or a scientific paper and look at what's going to happen in 50 years to see that something is changing and changing fast.
But there was a time when this data was not so convincing. How did climate science develop over time?
Yeah, it's a long and interesting history, which obviously I'm not going to try to recite in its entirety, but there have been some kind of rapid and remarkable and I think positive changes. The person that most people kind of credit with really sort of identifying this as an issue was a Swedish scientist named Arrhenius, who in 1896 identified that the chemistry of the atmosphere was such that it trapped heat, and that the gases that were responsible for trapping that heat, if they should increase in the atmosphere, would trap more heat and the world would get hotter. The hothouse effect, or the greenhouse effect as we now call it. And in the 1950s, so we're talking about 50 years later, we actually started to take measurements in an observatory in Hawaii, and we saw that the concentrations of the principal greenhouse gas, which is carbon dioxide, was and has been and still is indeed increasing. Then scientists said, well, can we model how, if this continues, can we model what will be its effect on the climate system? So when computers came along, they started to build the basic physics into primitive software on primitive computers, but now of course we've got you know, sort of supercomputers and very sophisticated models, and so the modeling has become increasingly sophisticated. And in that time period, that scientific evidence became persuasive enough that in 2015 we got the Paris Agreement to try to limit the warming to 1.5 to 2 degrees above pre-industrial levels. So that accomplishment of the Paris Agreement would not have happened without that 100 years of science, or you know, more than 100 years of science that slowly built up that evidence base. So even in my career, I've seen a big shift. People, even 15 years ago, you could read policy papers on the agriculture sector, and if you found climate at all, it was about the trade climate or the climate of uncertainty that was limiting investment. Now it's all about climate change, and there are billions and billions of dollars in investment going in because of these concerns through the World Bank, all the international finance institutions, and indeed governments. So things have changed, and they are changing. So we see signs of that, and I would argue that science has had a major role to play in that transition.
It's been, it looks like it's been a long process, right? A slow, some would say slow process. Wow. Sometimes on a more individual level, on a personal level, when we talk about 1 degree change in temperature is one of the indicators, but looking at precipitation and others, it is difficult to really imagine what would this mean, even today.
When you hear 1 degree, you think, so what? I mean, in a day, we can get a change of 15, 20 degrees, so what's the big deal? And, there are a variety of different ways to try to get a feel for what 1 degree means. I'll just give a couple examples. First of all, that doesn't mean that every part of the world is getting 1 degree warmer than it was 150 years ago. Parts of the world are 4 degrees, 8 degrees, 10 degrees warmer than they were, and most of those parts of the world are in the polar areas. So the poles are warming a lot faster than the equatorial regions, for example. And then you can say, okay, well, it's a good thing not that many people live there, but remember that those are areas that have a lot of ice, and that ice is melting like crazy. So the Arctic ice cap is shrinking dramatically and rapidly, kind of worst case scenario speeds, and the Antarctic ice sheet, which is a little bit harder to figure out what's going on, is showing signs now of thinning, and underneath the ice where it's harder to see it, there's been a lot of changes in the way the ice interacts with the ground surface underneath. And they're talking now about the potential for collapse of some of these major ice sheets in the Antarctic. The ice melting, it goes into the ocean, of course, and when you combine that with the thermal expansion of the ocean, by the way, is absorbing about 93 to 94% of the heat that is being trapped because of the increase in the greenhouse gas concentrations. So when the oceans get hotter and hotter, of course, they expand. Just hot things expand, cold things contract. Ice melt and the thermal expansion of the ocean will and is going to create sea level rise. And sea level rise is going to flood a lot of low-lying coastal areas. The last time the Earth was this warm in geologic time, the sea level was 6 to 9 meters higher than it is today. So if we froze the temperature at 1 degree, 1.1 degree, whatever, and we let the sea level reach an equilibrium with all the ice finishes melting and the ocean finishes expanding, we'd be looking at a sea level rise of 6 to 9 meters. That would flood where hundreds of millions, even billions of people are currently living. So, 1 degree doesn't sound like much, but when you play it all out, it will have and it is having major consequences. And 1 degree is we're not going to stay at 1 degree. The question is, how much hotter is it going to get?
One question that some people pose is, okay, climate has been changing for a long time, hasn't it? I mean, we've been experiencing changes looking back thousands of years. How is climate change today different from that?
That's an excellent question, and it is that whole spectrum of changes is all part of the overall field of climate science. So we can parse apart the kinds of changes that have occurred over the different time scales, and it is an ongoing project of scientific inquiry to continue to investigate the causes. So, to give some examples that people would be familiar with, there have been periods in geologic time when most of the Earth was covered by ice and snow. This area where we're sitting in Switzerland right now might have been under a kilometer or 2 or a mile of glacier, and we see evidence of that all over the landscape here. These kinds of changes are caused by changes in Earth-Sun relationships that happen over periods of tens of thousands and hundreds of thousands of years. So 100,000 years from now, we may very well have an Earth which has a lot more ice and snow on it than it does now. But 100,000 years from now is, of scientific interest, but I think for a lot of people, we'll let the people who, if there are any left that are alive then, deal with that. Our problem now with respect to climate change is due to the emissions of greenhouse gases in enormous, unprecedented quantities, including in geologic time scales. We're releasing carbon that was stored hundreds of millions of years ago when the world was covered with plants and slime and dinosaurs, and slowly all of that got buried and it turned into ook and goo, and now it's being pulled out of the ground as fast as people can get it, and it's being burned, and all of that accumulated over those hundreds of millions of years is being released in the atmosphere over a period of decades. So in terms of these long-term oscillations, this is like a house on fire, basically, in terms of the rapidity of the changes that are occurring.
I wanted to ask you, is there anything else you'd like to share?
So at the World Meteorological Organization, what we really focus on, we do support all of those things, but we focus on the facts. The last 5 years were the warmest 5 years on record. 2016 was the warmest year ever on record. This is not speculation, this is not a projection, these are facts based on observations. So it is important to look at those facts and look at those observations and then look forward, and this is something that hopefully will begin to trigger policy changes in technology, and changes in individual behavior that will begin to change the rate at which we use fossil fuels, how agriculture is done, and other things that need to happen in order to avert changes that could be, truly problematic or even devastating or catastrophic. The other thing I would say is that there is a very large role for lack of a better term, or maybe this is the right term to use, culture in all of this, because there's a lot of research now that shows that people's belief systems are very strongly anchored in what other people like them and around them believe. So a lot of scientists are scratching their heads. These facts are incontrovertible, you can see them, you can measure them, it's all based on science. Why is there any discussion about whether this is happening? And the answer to that seems to be that as long as there are enough other people around you who say that it's not, and people will that's what they influences what they believe. So we really need to get to some cultural turning points. I can lecture on and on about climate change and we need to do something, and then I get on an airplane and I fly around the world generating more CO2, probably per minute than an average person in a village somewhere, in a low industrial economy is generating perhaps in their whole life. So I know that these things are happening more than, most people, I would dare say. And I know that we need to do all these things, but have I changed my lifestyle and I'm now, sort of living in a cave somewhere? No, because why? Everybody around me drives a car and, flies on an airplane, so I do it too. So it is very difficult to predict when these kinds of these turning points are going to come about, but we need those kinds of cultural changes where suddenly everybody is riding bicycles, or everybody is consuming a lot less than they currently consume, and nobody can predict when those things are going to occur and to what degree they're going to occur and where. But this is what will turn this around, if it's going to be turned around, is these kinds of cultural changes in behavior, where what was acceptable once is no longer what people do.
Thank you so much for sharing all of this. It's been a great pleasure for me, and I hope that you've enjoyed as well.
Well, thank you for having me, and it has been a very interesting conversation, and I've really enjoyed it.